Hello everyone, I'm Lee. In this video, we are going to look at the third component of Java collection framework, that's algorithm. So algorithm is contained in java.util package, and the class name is called collections. It's not collection. Collection is an interface, and collections is a class name. Inside the collections class, we have many algorithms such as searching algorithm and sorting algorithm, shuffling algorithm. Now let's take a look. All these algorithms, although these methods, they're public and static, which means you can invoke those methods through the class name. Like you can say collections.addAll. And also let's take a look at the parameter, and most of them require you to have a list, or some are more general like a collection. So if you're wishing to use the algorithm inside the collections class, most likely you're going to convert it to a collection. And fortunately, remember when we have two interface hierarchy, one is collection hierarchy, one is map hierarchy. If you want to do something about the map and using the algorithm contained in collections class, you're going to have to turn the map into the collection. We have a couple of methods that allow you to do that. After you turn it into collection, pretty much every collection you can turn it into list. We will see. Okay, now let's take a look at the sample code. The sample code shows you a couple of methods inside the collections class. Alright, so the test algorithm one. The first thing we did is to create a list of students, and we built this list of students through this method, arrays.asList. AsList is a method defined in the arrays class. It takes an array. So take a look at student. Student is an array of students. It takes an array and turn it into a list. The reason we want to turn it into list is we want to use the algorithm contained in collections class, and most of them take a list as an argument. So after we turn students, this is an array, into student list, which is a list of students, and we can go ahead and use the algorithm contained in collections class. So the first one we use is the shuffle algorithm. So we just go ahead and shuffle the student list. And the second algorithm we use is the sorting algorithm. So you see how we invoke those methods. We just say collections.sort through the class name, because sort or shuffle or any algorithm inside of collections class, they're public and static. So you don't have to instantiate collections class to use the method. You can just invoke the method through the class name. Alright, so collections.sort will sort student list. You might be wondering exactly how the list is sorted. Are they sorted by ID, or are they sorted by last name, or by GPA? Exactly what? So let's take a look at the sort algorithm documentation in the collections class. So you see, this is a sorting algorithm we invoke, and the sorting algorithm says you have to give me a list of something. We did give it a list of student. So student is a T here. And also let's take a look at the restriction for T. T has to extend comparable. That means T as a class, it has to implement comparable. So let's take a look at our student class. This is our student class. It implements comparable. So when you implement comparable, you have to provide a method. You have to provide the implementation of a method called compare2. And you see, in our case, we compare student ID here. We compare student ID. So that means when we do the sorting algorithm here, it's using ID as a sorting criteria. So that one is called the natural ordering. So the natural ordering is reflected here. So the natural ordering requires the object inside of the list has to implement comparable. So whatever logic you use in this one, in the compare2 method in comparable interface, that will be the sorting criteria. So that's a natural ordering. And now let's take a look at another one. So let's take a look at this one. So we're using another sorting algorithm. And let's take a look at this algorithm. So the second sort says, you can give me a list of something, but this time that something doesn't have restriction now. But the second argument, it takes two arguments. The first one is a list to be sorted. The second one is a comparator object. The comparator object just tells the sorting algorithm exactly how do you want to sort the list, sorting by what. So that logic is inside this comparator object. Now let's take a look at the comparator. So comparator is an interface. Inside of this interface, it has two methods. One is used to compare two objects. You give me two objects, I'm going to compare them for you and give you back a small integer to indicate which one is bigger. And the other one's the equals method. Alright, so let's come back to our code. To use this second sorting algorithm, let's take a look at collections class. We have to pass in the list and the comparator object here. So let's see, how did we do that? Comparator object, let's see. Here we pass in the list, and the second one we say new comparator student. That looks weird because we never instantiate an interface before. So there's more. Let's see. Here we have something like this. So please pay attention to the highlighted one. Starting from a curly brace, then there's a method definition for the compare method. So here we are trying to compare the GPA to compare to students. Alright, so take a look at the starting curly brace and the ending curly brace. Actually, this is a class definition. And inside this class, you have a method definition here. So this class is strange because this class doesn't have a header, doesn't have a name. We don't have a class like class compare or something like that. So it's just a class without a name. We call it anonymous class. And this class implements comparator object, comparator interface. So let's take a look at this second argument. The second argument create an object of comparator. Actually, it's creating an object of this anonymous class. Since this class doesn't have a name, so it uses the interface name to create an object of that one. And this object is the second argument to this sorting algorithm. So this language construct shows us we are trying to create an object out of an anonymous class right inside the second argument. That's what's happening. So we are defining the class and instantiate the class at the same time inside this parameter list. So you see this parenthesis is the end of the parameter list, and this semicolon is the end of this sorting statement. So this is called anonymous class. You might be wondering, why do we want to use an anonymous class? Why don't we create a class with an appropriate name? Let's say class compare by GPA implements comparator interface. You can absolutely do that. So that's perfectly legal. Then here you just say new compare by ID that class name. So that's perfectly legal. But the reason people use this kind of like embedded class, anonymous class definition is this might be the only place we use this class. And just for convenience reason, we're going to define it right here and instantiate right here. Okay, when we instantiate, we use the interface name, because this class doesn't have a name, but this class implements this interface. So this is a place we instantiate a newly defined class in the argument. Okay, so that's about this second sorting algorithm. We gave it a list and we gave it a comparator object, and we define that anonymous class right here. Alright, so that's another example of using this collections class. So again, inside of this collections class, you can find lots of useful methods that frequently used algorithm. And when you need to use it on your collection, just look it up. Alright, that's about the algorithm part of the collection framework. Thank you.